Hello and welcome to the GCSE Physics tutorial for topic P5 forces. We'll be looking at part 3, forces and elasticity, moments, levers and gears, and pressure in fluids. First of all, forces and elasticity. An elastic object is one that can go back to its original shape after the force has been removed. If it doesn't go back to its original shape, it's inelastic. Most elastic objects you'll have to look at in the physics topic are springs. When a spring is stretched or compressed or bent, the energy is transferred to the elastic potential energy store. Remember that term from the energy topic. One of the practicals you will need to know is how to investigate springs. The calculation you need to know is force equals spring constant times by extension. Now, the extension of a spring is how much the spring changes in length, and that is directionally proportional to the force. So if you double the force on the spring, you will double the extension. This is until a point, and that is called the limit of proportionality, as shown on the graph. After that point, extension and force are no longer directly proportional, and different springs will have different limits of proportionality. To carry out this investigation, you would need to set up a spring in a clamp stand and fix it next to a meter ruler so you can see the distance alongside the spring. Sometimes it's useful to put markers at the bottom of the spring so you know exactly where the length is changing. You'll then add masses to the spring and each time mark the change in length and then calculate the extension, so how much it's stretched. And you would need to repeat this at least 5 times to get 5 results that you can plot on a graph, as shown here. Moments. So a moment of a force is force times distance from the pivot. And a moment is the turning effect of a force, and the pivot is in the centre as shown in the diagram. If the total anti-clockwise moment and the total clockwise moment about a pivot are the same, then the object's balanced and will not move or turn. However, if you apply force, then this causes a moment on the pivot and allows it to turn. And this is how spanners work, because a larger force or a bigger distance from the pivot creates a larger moment and allows the nut to move. Another example is a door handle. Levers. This is an example of a lever, and these increase the distance from the pivot, which means you don't need as much force to get the same moment, and that means you can lift heavy objects using a lever. Gears can also change the moment of a force. A small gear can be turned, and that can be used to turn a larger gear. And this is because gears transmit rotational effects of a force from one gear to another. Pressure in fluids. There's 2 calculations for pressure. Pressure equals force divided by area. Pressure also equals height times density of the liquid times gravitational field strength. The pressure of a fluid depends on 2 things. First of all, density. The more dense a liquid, the more particles are in it, and that means there's going to be more pressure because there's more particles. Also, as you go deeper, there are more particles above that point, so therefore there is more pressure. And that explains, if you look at the diagram, why dams are designed to be thicker at the bottom, because there's more pressure from the water at the bottom, so they need to be thicker to withstand that. Upthrust. This is also an important force. When an object is in a fluid, the pressure from the fluid exerts a force all over that object. And the force at the bottom is bigger than the force at the top, and the overall resultant force is called upthrust, and this is a force that allows objects to float. If an object floats, its weight equals upthrust, and the object is less dense than the fluid. If its weight is bigger than the upthrust, it will sink. Atmospheric pressure. This is the pressure in the atmosphere, and that's the layer of air surrounding the Earth. As you go higher up, or as increasing in height or increasing in altitude, then the pressure of the atmosphere decreases, and that's because there's less air as you go higher, and so the air is less dense. There's also less molecules of air as you go above, and so there's less pressure. If you pause the tutorial and try these questions now. The limit of proportionality is past that point, extension and force are no longer directly proportional. If someone weighs 200 newtons and sits 1 metre from a pivot in a seesaw, where would someone who weighs 400 newtons sit to balance it? Well, you can see from the calculation you would do 200 times by 1, which gives you 200, and then 200 divided by 400 newtons, which is 0.5. So it's balancing on both sides. How are levers useful? They make it easier to lift a heavy load. And that's because as you increase the distance from the pivot, less force is needed to make the same moment. In summary, we've looked at forces and elasticity, moments, levers and gears, pressure in fluids, and the practical investigating springs.